Alright, course 2, here we are, lesson 100. Woohoo! Estimating square roots and irrational numbers. Secret word, gravel. Alright, so you can recall, right, that perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, etc., etc. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times, etc., right? So perfect square is a number times itself. So the root of a perfect square is an integer. Remember, an integer are all whole numbers, including the negatives, and 0. So it's always an integer. All right, now, the square root of a number that is in between the perfect squares is not an integer, but can be estimated. So if someone says, all right, what's the square root of 29? I don't know. Well, we know that 29 is between the square root of 25 and the square root of 36. So the square root of 25 is 5. The square root of 36 is 6. So the square root of 29 is going to be somewhere between 5 and 6. And because 5 is 25, 6 is 36, it's going to be closer to the 5, right? But it does not have, you cannot, it just goes on and on and on and on and on forever. All right. Irrational numbers. Between which two numbers is the square root of 200? Well, we see that the square root of 100 is 10, so it's more than 10. So let's guess 20. Well, 20 times 20 is 400. Well, that's too large. So let's try 15. 15 times 15 is 225. It's too large. It's sort of like the Goldilocks and the Three Bears. Let's try 14. 14 times 14, 196. Aw, too small. So, what do we know? We know then that the square root of 200 is somewhere between 14 and 15. 196 and 225. So let's go back to the square root of 29. We know it's between 5 and 6, right? So try some decimals. 5.4 times 5.4, you get 29.16. Well, that's too large. Well, let's go over here. How about 5.3 times 5.3? 2809. That's too small. Well, what if we used a calculator? Well, the answer would be 5.3851648. But that's not correct either. Why? Because it's not a rational number. It is an irrational number because these numbers actually go on and on and on and on and on. You can try it if you want. Irrational numbers. Definition of an irrational number is a number that cannot be expressed as a ratio of two integers. But 29 does have an exact value. What? Let's look. Remember the Pythagorean theorem? 2 squared plus 5 squared should equal 6 squared. So I have 2 squared plus 5 squared, oh, that's a C, equals C squared. 4 plus 25 equals 29. So the length of C is the square root of 29. I know, weird math things, but we can use it as an answer even though it's not a rational number because it is an irrational number. Pi is also an irrational number. 3.14 goes on and on and on and on and on and on. So guess what? We are welcoming a new member to our set of numbers. It's called real numbers. That's the top dog. It includes all rational numbers and all irrational numbers. Remember, we have integers, whole numbers, counting numbers. Here's the top dog, real numbers. Covers all rational and irrational. So they are going to ask you quite often to put square roots on a number line when they don't really have a perfect square. So let's say we have pi. Well, we know that's 3.14 something, 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 something. We know that the square root of 2 is going to be between the square root of 1, which is 1, and the square root of 4, which is 2. All right, so it's going to be between 1 and 2. Then 2.333333333, on and on and on. It's going to be somewhere in there, and a half. Remember, repeating decimals are rational. All right, because this repeats 3333333. It doesn't go 3, 1, 2, 7. Okay, it's repeating. So let's put these on the number line. Well, we have negative half is going to be halfway between -1 and 0. The square root of 2 is going to be somewhere between 1 and 2, right? 2.333333333. It's going to be closer to the 2 than the 3. And then pi would be closer to the 3 than the 4, because pi is 3.1 for something, something, something. Okay, just let that soak in your brain. It's not hard, it's just weird. All right, so which type of decimal numbers are irrational, repeating, terminating, or non-repeating, non-terminating? Ding, 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 ding. Non-repeating, non-terminating means it just goes on and on forever, but it doesn't have a pattern. Those are irrational. All right, each square root is between which two consecutive whole numbers? I want you to copy these down and turn these in with the rest of your assignment. So the square root of 7. Well, what's the square root of 4? Square root of 4 would be 2. What's, actually you can just go up the numbers. So 2 times 2 would be 4, right? 3 times 3 would be 9. So it's got to be somewhere between 4 and 9. So if they ask you that, you go 4 through 9. Somewhere in 4 to 9. How about 70? Well, what square root do I know that's close to 70? I know 8 times 8 is 64, right? And I know that 9 times 9 is 81. So it's going to be somewhere between 8 and 9. How about 700? 700, oh my goodness, well, we know the square root of what? Let's see, 100 times 100 is 200, 200 times 200 is, oh no, Mrs. Van Zalen, what are you doing? Okay, so we know that 20 times 20 is 400. We know that 30 times 30 is 900. Oh, that's too big. That's too little, so it's going to be somewhere between 400 and 900. Oh, look at that. We're making a pattern. 4 through 9, 8 to 9, 4 through 9. Okay, do you get what I'm doing? I'm just multiplying numbers times themselves to figure out where this fits, right? 2 times 2 is 4. 3 times 3 is 9. Oh, so it's got to be between those two. All right. Sometimes you are going to get an answer that's just going to be irrational like this. So here says find x. We're going to do our Pythagorean theorem. We got 1 squared plus 1 squared equals x squared. Well, guess what? 1 squared is 1 plus 1 squared is 1. So that would equal 2 squared. And what's the square root of 2? Well, we can't figure it out, so we just write it as square root of 2. So those would be easy answers, right? You just put it in its radical form there in that thing. All right, how about if we have this one? We have 2, 1, and y. 2 is going to be the hypotenuse. So we have y squared plus 1 squared has to equal 2 squared. Well, 1 squared is just 1. 2 squared is 4. So what has to be there? 3, right? Well, yeah, 3. But we need it to be the square root of 3. So the answer is the square root of 3. Right, because it's 3 squares, so it would be square root of 3 is what this would be. So now put it on the number line. Okay, we have the square root of 3. We have 0.333333333. We have pi, and we have negative a third. All right, well, negative a third is just going to be 1/3 of the way here. So that's negative 1/3. Yes? Yes, it is. The square root of 3 is going to be between 1 and 2. Right, square root of 3 is going to be between 1, which is 1 times 1 is 2, 2 times 2 is 4. It's going to be somewhere in here. I'm just going to put it right here. Square root of 3. 0.3333, that's not quite 1 yet, right? It's going to be closer to the 0. 0.333333333. And pi, it's going to be 3.1 something or other, 3.14. Oops, you can just write pi. Okay, so they're going to have you do that, so you need to be really good at it. Just let that soak in. Yeah, good job. Okay, your assignment. You're going to copy those down, so I'm going to be looking for A, B, and C on your paper, D and E, all of those. I want you to copy all, ooh, and F. All of that we just did, put on your paper. Okay, then you're going to do 4, 5, 6, 7, 8, 9, 8, 10. 11, 12, 13, have that done before class. Then 14, 16, 17, 18, 20, 21, 22, 23, 24, 25, 26, 29, and 30. Remember, the secret word is gravel. Write it down. You get 5 points. Do it. Okay, see you in class. Good night.